This is Astronomy Daily Live. Hey, 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 everybody. Hope everybody's doing well. Happy day, happy evening, happy wherever you are. Hey there, Bobby. Just popped into the panel. What's going on? Oh, you're all dark. Can't hear you. I'm turning you down anyway.
Hey,
There you are. What's happening?
hey, are you using your headphones or your speakers?
Oh, I got to get my headphones on here. Got to attach my head. There we go. Is that better?
Yeah,
So what's going on, Bobby?
nothing much.
Pretty much the same. It was a pretty interesting day. Just just finished. So I went to work as normal, and I was sitting there doing my thing, and got this phone call saying, "Hey, our fridge just died." I'm like, "Oh man."
Oh man,
It's like,
no, I saw a crazy. I saw a crazy video today. If it was your McDonald's and there's like an employer forgot that her microphone was turned on and she was doing a phone conversation and you could just hear it from the box in the drive-through area. What would you do?
That's crazy. That's wild. Yeah, yeah. So anyway, the interesting thing is uh, with the fridge is that it just so happened that that my boss had just replaced um, a fridge that was actually there at the lab, and we had like just put it outside with a sign saying, this thing works, it's free, just take it. So I'm like, hey, you know what? I know where I can get a fridge for free. So yeah, that's what happened. I finished up a little bit of work and then packed that thing into the truck and brought it home, and it is packed. It's packed. So it seems to be working okay. Thought it was. So yeah, yeah. So that's about as exciting. That's about as exciting as I want it. So I can only handle that once in a little while, right? I just can't handle that kind of excitement. So cheers.
Yeah, and welcome to Tom Van Scholar and Catherine 313. Welcome.
Hey there. Welcome. I'm gonna pop up my you know what? I need to do the Linux thing, and I need to look at my chat. Now, it looks like I have two chats. I don't know what that one is. There we go. Yeah, so hey there, Tom. Catherine 313. Nice to see you again in the chat. So hope everybody's well. Yeah, that's about as exciting as I want it, and I think relatively speaking, that's not very exciting at all. So if that's the extent of the problems I have, then I'm doing really well, and that is the extent. So come on in, friends. Let's gather around in a circle and or sort of the virtual lounge, right? We're out on the back porch, and we've got our feet up, right, and our drink or consumable of choice, and just sitting back, sort of, forgetting about sort of everything else for an hour-ish or so, and just think about astronomical things. Just don't really think about much of anything else. Um, Now, sometimes there's going to be some tangents, and I think any tangent that we go down is going to be, is going to have some kind of relevance, right? So maybe a tenuous one, but that's okay. Hey there, Uncle Bill. Thanks for coming in again. Uncle Bill uh, has been supporting me almost from the beginning, almost maybe a couple weeks in. Don't don't remember how that worked out. I sort of am intentionally not keeping track of how long this is going, or how many how many days or how long ago I started. I don't care about any of that. I'm doing the Zen thing, and that is my goal, right, is to do today's live stream. Period. So I think that breaks it down into what's hopefully a very tasty and digestible uh, hourish or so of astronomical stuff.
You did say that it was a good HOS this week.
I did say, did you listen to it?
Yes, I did.
Yeah, yeah, yeah. What do you think?
It's okay. I like it.
Okay. Yeah, as I said, I was particularly blown away by the last three songs. I don't remember how many they played in the entire hour. Maybe six or seven. I'm not quite sure. Um, they vary in length depending on what the artist is trying to do. So, but the last three I think are pretty long, but they're pretty amazing. Get some headphones on and listen to those. The whole show was really really great. Um, they put together some artists that I recognized and already like. Uh, One that comes to mind is Chronotope Project. I think that's the name of them. Um, they're they do some pretty interesting stuff, and I think one of those last three songs maybe was them. Not quite sure. I'd have to look at the list, which is easy enough to do. Should we do that like really really quick? I found a couple interesting papers, related papers on archive that I wanted to share because it sort of nerds out on some hardware. But let's go over to oh, now I lost my train of thought again. Dang. Where was I going to go, Bobby?
To that paper that you had in your Discord, I think it was.
Oh, yeah, no, I was going to do something else first.
Oh,
Oh
I
man.
don't know either.
I don't that that train just totally left the station, huh? That's kind of annoying. Um all right, well, let's dive into these papers then. They're building a new telescope. And I think, well, it's going to be replacing a telescope that already exists. And I believe that that telescope is on Maunakea. So Maunakea is the uh, I'm pretty sure that's the highest peak on the island of Hawaii. You know, the actual island, not the state. Um, so that is the Big Island. It's got, you know, Kona and Hilo, um, and these two big volcanoes, right? One active, one hopefully not. Um, and Mauna Loa, you've probably heard of. That's the active one. And Mauna Kea is what is, you know, the destination of any um, serious astronomer is uh, um, the telescopes at Mauna Kea. That's like an awesome, awesome, awesome thing. That's like walking on the moon. You know, it's like this is awesome.
And
So
that's going to be
yeah,
a space telescope or regular on the ground telescope.
this is going to be a regular on the ground one, um, but it's going to specialize. It's going to specialize in spectroscopy. It's not going to do anything else except spectroscopy. So it's not going to actually take any images of the sky. What it has, okay, it's this big scope. It's like I think we can look here. Um, it's like an 11-meter segmented telescope that is going to be uh, only used for spectroscopy. So this is what they call the conceptual design review. So this is just um, you know, they've come up with some kind of concept, right? And that concept has gone through this um, review. So, you know, they send this concept around to, you know, hopefully unbiased individuals. It's a lot like refereeing papers, right? And those individuals will, um, I'm not exactly sure what the procedure is exactly, but my guess is that it would be something like, you know, they check a box. Do they approve or don't they approve? And then if they want to, they can write stuff, and they probably all do. Uh, that's my guess. You know, uh, either compliments or criticisms with recommendations. Um, you know, that kind of thing. But anyway, so that has that has apparently happened in this case, and so they published this just to, you know, say we're done with this phase, and that's very, very cool, right? Because then it can actually move onward towards the preliminary design phase, um, ending with a preliminary design review. Once a PDR is done, they can start like actually doing stuff, you know, cutting metal and grinding mirrors and whatever they have to do, right? Uh, so yeah, they've got, you know, this is sort of the first step. Um, so it's going to be replacing the existing CFHT, which is 3.6 meters. So they're taking that scope out, right? And from what I saw, they're taking the dome out, they're taking everything out, and I'm replacing it with this because it's actually a cool looking dome. I think. Well, we'll get into it here, but I think I've seen those before. But so yeah, let's. What I really like about this paper is pictures. So this is the design that they thought of um, going into the review. And let's zoom in a little bit here, and we can look around and see. Now it's a little blurry, so my apologies for that, but that is the resolution of the picture itself. So I have no control over that. So obviously the telescope structure is in blue here. And then there is the primary mirror. So it's 11.25 meters using 60 1.44 meter hexagonal segments. So it's a lot like Keck, right? Keck is basically the same size, and I think they use about that many. So it is basically a Keck. So that's cool. That's very cool. Um, but as I said, this telescope is not going to be used for imaging. It's not going to take any pictures at all. What it's going to be is a big feed for a bunch of spectroscopes. And let me tell you, they're ambitious here for sure. Let's see. So this is what they thought of before the review, and then here's some dormitories. Here's the pier, right? So this is a concrete. The telescope actually sits on, and as you can see, the telescope is not actually connected to the dome in any way. So that prevents vibration, either from the ground or people walking around would cause possible vibrations. And when they're trying to be extremely precise and everything, you don't want some heavy-footed dude walking around um, uh, you know messing up the light paths. So that's what they started with, and this is what they ended up with. So they buffed this up a little bit because they knew that this was sort of going to be it, right? So here's the dome. It's called a colette or a calotte style. I don't know exactly what that means, but I'll show you a picture soon. So what this does is it allows astronomers to collect up to 4,332 separate spectra. You can position these optical fibers anywhere in the field of view, and you can transport that light down to quite a number of spectrometers, and the data is a good thing. but it's not going to be taking any images as far as I know. As far as I know, there are not going to be. Okay, so there are 4,332 positioners, but it looks like there are only 3,249. Oh, okay. No. There it is. Just looking at the sum. Okay. So yeah, so 4,332 possible positions for these spectrographs. And they have low resolution, moderate resolution, and high resolution. So very cool. Let's see. Telescope structure. So pretty awesome looking, right? Great big toy. I like it. See, I don't go for these, little cars and little rockets or amateur telescopes like the kind I have. No, I like the big toys. These are fun. I think that's why I never got the fever, because I've worked with some pretty big instruments. So yeah, I never got the fever. I was cured. So that's the outcome from the review. So I think either of those is awesome. This one, they've got a little bit more specificity, and I think they've actually gone so far as to know who's going to make each piece. Right? They even have manufacturers lined up. So yeah, here's the initial design and the conceptual design. So you can't have a project without charts. Yeah, lots of instrumentation. Let me back up a little bit. So there's the instrument itself, the MSE, they're calling it, the Maunakea Spectroscopic Explorer. So that's a pretty cool name. That's right, Uncle Bill. Yeah, you have to take a heroic dose. You have to take a heroic dose, and then you will transcend aperture fever. But just a heroic dose. You don't have to overdose. It's not necessary. Oh, there we go. All right, so we got the, come on. Got the observatory building, the dome, right? They're calling it the rotating enclosure. Got the telescope, all the science instruments, observatory exclusion system. Don't know what that means. Program, execution. I'll bet you that says execution. Yeah. So observatory execution system architecture. So that's the telescope control system. And then the program execution system is probably the thing that tells the machines where to put the fibers. Yeah, queue service, data reduction. Yeah, so this handles all the data, and as I said, probably the yeah, what controls the science instrument? Oh, I guess right there. Instrument control sequencer is under the observatory execution system architecture. Cool. So pretty cool. Facilities and shops and labs, other spaces. Let's see, the rotating enclosure. You got the structure control system, the enclosure utilities. Yeah, I mean, of course, it needs power and enclosure safety system. Yeah, domes can be deadly. Um, you have you know when you're in uh, any observatory um, uh, with and it's more than just you. You have to communicate because it's way too easy. It's way too easy to get yourself into a situation where you're going to get hurt or killed. There was actually there was an astronomer killed up on Kitt Peak, up at the 4 meter, the big one, and yeah, he was walking around on the catwalk outside, and there are doors, there are access doors, and yeah, he found himself going through a door when the dome began to rotate, and bye bye. Yeah, just messed him up good. So yeah, you got to be careful. You have to communicate. Nobody knew he was out there, so he didn't tell anybody, and uh,
So,
that's what
like, he
happens.
died or he got injured?
Oh, he was chopped in half. So yeah, uh, pretty instant. Um, but yeah, that was I think that happened like in 1980s. I want to say 85, 86.
Yeah, but did he survive or did he die?
He was very dead, very dead. Yeah, when you're chopped in half, you are you're not likely to survive.
It's not like in those magic shows. So sorry.
It's not. It's not. So anyway, yeah, safety system. I like to see that. So then, the telescope, of course, is really complicated. Let's see if there's anything that sort of okay. So yeah, so here is the optics system, right? They have to be able to um, keep all these segments um, aligned really, really, really well. So yeah, that's a big job. Whoop, that's a big job. Instrument rotator. It's a alt azimuth telescope. So from its point of view, as objects uh, move through the sky, they not only move from east to west, but they appear to rotate. So it's just a difference between um, equatorial rotation, where you're rotating around a pole that's at some angle, and um, rotation where you're rotating around your zenith point. So that difference in angles causes what looks like a rotation in a alt-az mount. You don't see that with an equatorial mount.
I had to say
And,
hello to R. Astro, and he said they'll buff out.
all right, well, yeah. Well, one would hope so, Arenstro. Hope everything is well over on your side of the planet. Holy moly, it's great. It's great. What a great circle we are building here, slowly but surely.
Hope everything's peaceful over there, R. Astro.
Yeah, yeah. Little a little exciting over there, for sure. So much, I mean, it's such an amazing culture, right? I mean, and it's ancient, right? I mean, it's prehistoric, and ah yeah, I hate to see all the fighting. It just seems, I don't know. I mean, they think it's important, but I don't know. Let's get back to astronomical things. That makes me feel a little better. uh, so yeah, the what? Oh man, I keep doing that. So the observatory execution system um, architecture handles operating the telescope more or less. There's a data management system in here. Here's the telescope control, instrument control, facility control. Interesting. And then, yeah, as we already looked, this is sort of, data handling. Gobs and gobs and gobs of data. They're talking about, I think they actually talk about it here. Let's see. So there's that. Let's see if we can get some numbers here. Is it back here? Let's see. Yeah, I'm not seeing it yet. I guess it's down a little ways. So pretty exciting though. These are the plans to build a brand new telescope. So, I thought it might be interesting to look at this. I don't know if anybody sees these kinds of things, but it definitely piques my interest. I get to sort of nerd out on big instrumentation and uh, yeah, see what uh, see what they're doing in a little bit of detail. I think it's pretty cool. So
I
this is
like that from Uncle Bill. You can't ban people from a Doctor Who villain.
yeah. Yeah, I unfortunately, Uncle Bill, I have to agree with you. So I think it's all we can do is try to have as much fun as we possibly can. As I ultimately think that's at least part of what it's all about. Is just sit back and enjoy, right, and participate. Um, and you know, if that's at least half of what it's all about, hey, I'm good with that. Uh-oh. I now have a kitty in the lab. All right, so let's keep going here. engineering status. Well, I'm not quite sure. I'm not quite sure what the difference is between what we just saw and this, because it looks the same. So I don't really know what's going on there. So here are some highlights from the reviews. I think that's great. So structure, right? So here they've identified who is going to build the telescope structure and the enclosure and the spectrograph itself, right? It's going to be a Chinese spectrograph. Is that cool or what? Positioning system of the fibers, Australia, China, Spain. It's awesome. Fiber transmission system, Canada. I think the Hertz. Oh, okay, yeah. So the software is going to be written by the programmers at CFHT. That's cool. Give them a job, you know. Top end assembly. Not quite sure what that means. And then another spectrograph. Did they say anything about the mirrors? Ow, ow, ow. I don't think they said anything about the mirrors. You know, the hexagonal mirrors? Let's see, Table 1 summarizes the major findings and recommendations of the review panel for the 8 subsystems reviewed. I don't know, maybe that's part of the structure, but I would think that the optics would sort of be a different category. Complete the conceptual design, missing on the lens mounting design that's based on an optical tolerance budget. Okay, this is actually, you know, sort of a criticism, right? I mean, it's okay, but they're recommending this thing. I don't know what this is. A delta CODR? I don't know. That's a little, not quite sure what that is. Do you have any idea what that is, Bobby?
Now, what are you talking about?
This delta CODR here. You know what the delta means at the beginning? I don't have a clue.
A delta CODR? Probably not.
Yeah, no, I don't either. But anyway, they're recommending it, whatever that means. But it looks like, oh, look at this too. Wow. It says design not mature enough to proceed to the preliminary design phase. Wow. So huh. I wonder how does that jive with getting through the CODR and moving into the PDP. I don't know if it says that it's not mature enough to proceed into that, then wouldn't that sort of halt the whole thing? I don't know. Let's see.
I don't know if the delta CODR is gonna work or not.
Well, I wish I knew what it was, because then I would sort of know a little bit more about what they're talking about. Yeah, so that's kind of interesting that the fiber transmission system um, is they're saying isn't ready to proceed, but it looks like they actually are though. So our instro says, I'm not sure the base physical optics are terribly cutting edge despite their size. Yeah, yeah, no, I totally agree. I think you nailed it. Um, our instro, the yeah, segmented optics like that. As I said, I mean it's Keck, right? And they've been running Keck for what 15 years now or something, maybe more, maybe less. I don't remember.
They say that code DR is a conceptual design rebuild, says Tom Van
Yeah,
Scotter.
yeah. Well, that part I understand, right? I mean it's a CoDR, but I don't know what a delta CoDR is. Don't have a clue. That's uh, that's a new one on me. So pretty interesting though. Let's see if they've got anything else here. They've got this really detailed table which you probably can't even read. Oh, you actually can.
Now, can Delta just mean another version?
I'm not sure. I don't know how to interpret that. Positioner attributes. Okay, so this is talking about um, what their criteria is in terms of how well can this positioner work. And so let's see. They don't have any numbers next to them. That's a little strange. So yeah, I don't see any numbers here.
Check the chat.
Yeah, I'm not sure, Tom. Not sure. That if that's a guess, that's as good a guess as I could come up with. Yeah, I don't know. I don't see any numbers here. It sort of looks like there's supposed to be, but I don't see any numbers. So I don't know what's going on there. Huh. Huh. Just empty boxes. Well, that's a little disturbing. You know what? I've got that same paper over on my Linux machine. I'm going to look at that. Oh, I'm looking at the wrong one. Let's go back. There we go. Sorry, I I just want to see if the same thing is happening on my Linux machine, because then if it's some kind of weird Windows problem, no, it's blank on the Linux side too. So, they they uh, they haven't filled in their boxes, but we can sort of look at what they're looking for. We don't have any numbers, but so yeah, they're the accuracy has to be at at least microns. Closed loop error has to be microns. A lot of these are microns because it's a positioning thing. Um, Configuration time. So that's talking about if they have to do anything with it, right? Um, Once they know where they're going to point everything, how long does it take? Sort of my guess. Accuracy again in microns. Stability. So, set it, I assume, set it to a position and see how well it stays there 30 minutes later. FRD, I'm not quite sure what FRD is. Attenuation loss, not quite sure what that is either. So robustness against shock and vibration, I guess that's probably not grams, but G's, G forces. Just sort of inferring that, right, from what they're looking at. Fill factor, more than one L, yeah, not quite sure what that means. So minimum distance between two fibers in millimeters, which are positioners. Yeah, again, I'm not, oh, okay, this is low and medium resolution, LMR, and HR is high resolution. And I think there were what, like 3,000 and some low and medium, and there were about 1,000 high resolution ones. Okay, so that's what that is. The focal surface, of course. All right, let's back. So yeah, I guess we'd probably have to get into the paper a little bit more in order to really understand what they're talking about here. I mean, obviously you don't, or you can't, right? You probably damage things, or, just physically not be able to get two or more fibers too close to one another.
On the chat, Cosmic, they were still talking about that Delta Code DR.
Okay. What are you? Yeah. Yeah, Uncle Bill, as I said, if that's a guess, that's as good a guess as I can come up with too. So yeah. Cryptic language sometimes. That's how it goes. So yeah, as I said, I'm not exactly sure what this is. They're calling this Sphinx, which I think is I'm not quite sure. It's an instrument. Okay. Sphinx must be the device that actually positions the fibers. Yeah.
The bit about attenuation probably has to do with signal loss due to the use of the positioner.
Yeah. Okay. Interesting. Yeah, certainly, I'm not going to recognize or understand a lot of this. But yeah, thinking out loud, yeah, that sounds about right in terms of attenuation. Yeah. So let's see. Selected multiplexing configuration. So I'm not quite sure what this is. I'm not quite sure where the multiplexing is taking place. If this is the multiplexing, or if these are the multiplexing. Sometimes these things are hard to read.
Art Astro, I had the biases where moving antenna reduced the signal, regardless of whether we were tracking closer or further from an ideal orientation.
Huh. Okay. Yeah. Yeah. So after a series of subsystem reviews, conceptual design phase culminated in January 2018 with a system design review to determine if the Maunakea, what they call it, Maunakea, the cheat, Spectroscopic Explorer. Whoop, where am I? Here we are. Will meet the science requirements. Um, so according to our scoring scheme, the minimum risk exposure can range from 2 to 64. Um, so currently, the technical risk register has a total of 8 risks. One low score of 8, 6 medium range scores from 12 to 24, and one high score of 36. Okay, so now they're getting into, and again, they're, I don't know if they're excluding numbers here. I'm not quite sure what's going on there. So this is just to achieve the science requirements. Okay. So, well, yeah, but still, I mean, if a piece of hardware isn't ready, how's that going to uh, meet the science requirements? I don't know. Anyway, then they start getting into you know, various weird stats, and because they're trying to be fair in terms of an assessment, right? They're trying to remove their own biases, and which is really, really hard. And so, and scientists, like to do these kinds of analyses. It's like totally nerding out, right? I mean, you don't really have to do this. So I want to, I'd like to see a statement, right, saying, yes, we approve of this.
Would have been better.
Yeah. And I think it's in here, but maybe, it's sort of hidden. I don't know. I mean, they're saying, to this end, we have issued a call to the astronomical community to join the MSE International. Ooh, they missed that one. International Science Team, with a goal to reaffirm the science case prior to starting the DRS process. I think DRS is design, review, I don't know. And oh, no, that's DRM. Do we know what DRS means? Usually they'll spell it out once, right? And then they use the acronym. That's why I'm going backwards. C. This is the kind of stuff that you have to do. It's sort of a pain. It's like, it's all we want to know is, what is DRS? Design Reference Survey?
Yeah.
Cool. Oh, I passed it? Well, I'm not surprised. Probably find it. Design Reference Survey. One of the strongest recommendations for the review panel is for the project to develop a design reference mission, aka the design reference survey within the MSc project. The review panel stated for a survey-driven project like MSc, the DRS is an enormously useful tool for evaluating at every stage whether or not the science goals will be met.
So the DRS, they can approve it or not, right?
Well, I guess how, oh, okay, here, look. The DRS is a narrative document that distills the science requirements and science case into an executable survey plan for early operations, taking into account both external constraints as well as technical constraints, using design information collected at each design phase. So it represents a step-by-step plan to execute the envisaged observations. Cool. It also will identify a precursor astronomical data sets. That's kind of interesting. That's kind of interesting too. So they're sort of gonna know what they want to look at before they look. So cool.
Interesting.
Yeah, I sort of thought somewhere in here, I thought it was near the beginning, they actually talk about how much data they're planning on getting out of this thing. Let's see if it's down here. I thought I saw it. Oh, here's a okay. Here's a example of a PDP work plan. So of course it's all laid out in dollars there.
Now, can Congress take a look at this as well?
No, it's not necessary for governments to necessarily be involved in this at all. They've, these individual institutions have sort of pooled their resources to do this, and so one institution builds the dome, right? One institution builds the telescope. Somebody else builds a spectrograph. Somebody else does this. Somebody else does that, right? But so check out this dome. Okay, this is what is currently there, and this is what they're going to replace it with. So look, it sort of looks like maybe the bottom part stays, but the water tower goes. They've ripped it out of the ground. Look at that. There's this post there now. But this is a pretty interesting opening. Usually we have a slit like this, and then we have doors inside that open and close. And the telescope can look along this entire opening. But they've designed this dome to be, a little more domey, right? You see how this goes way down here and this sort of stops here. But it has this like an iris or something, right? I mean, it looks like sort of like the Death Star, right? With a big, device there. Yeah. That's, I mean, there are science goals, and the science goals sort of drive everything else. So, everything sort of falls from the science goals. And so, and that includes the engineering goals, right? Because ultimately what it takes, right, is putting things together um, in order to get the data you need in order to do the science that you want. So I think it's pretty cool, that this is going to be, such a large telescope uh, is going to be used, just for that, just for that. And what's nice about that, right, is that they can seriously fine tune all the instrumentation, um, um, the telescope itself. They can fine tune the dome, and that's probably why they have this. They found, you know, maybe for some reason that you know, when you have an open slit, maybe there's extra light, and it's significant enough, to redesign that. So yeah, they can really, really tailor this kind of observatory to the instrumentation and ultimately, the kind of data that they want to see, which in this case are spectra.
Now there is like no other observatory that's able to do this yet.
There are observatories that have this kind of instrumentation where you have a bunch of fibers that can be positioned around in a field of view. Um, I think what is setting this one apart um, uh, is probably the number of fibers and um, the aperture of the telescope. They'll be able to see really faint stuff with this. So that'll be great, because it always seems like the interesting stuff is just beyond our reach.
One of the funny things about building new science instruments is that you build them based on theory.
Yes, yes. One of the interesting things, and I don't know if they say it in this paper or in the other one I put over on my Discord channel, but the interesting thing about that, our instro, is that they are using instrumentation and technology that has been tested, has been used, um, um, you know, with other applications. So they're just sort of putting a whole bunch of currently existing technology together into one package, right? So you have a big telescope like Keck,
Yeah.
and
But that's what that second part comes in. You don't know for sure unless they get it built and working.
oh yeah, absolutely. That is absolutely true. And there is going to be uh, there's always trouble, right? Always. That's just how things go. I mean, if things were easy, I think we humans would get bored, right? So yeah, doing this kind of thing is really, really hard, and you ultimately don't know that it's going to work until you flip the switch, right? And see if it turns on. So pretty exciting. It's going to be replacing um, a um, uh, replacing current telescope, a 3.6 meter telescope, and you know, kind of interesting that a 10-meter telescope can fit into a dome that used to house a 3.6 meter. Pretty amazing. This caught my eye. calculated using a universal labor rate. 110 US dollars per hour was used for this work. So that's a combined, right? That's everybody's pay, right? That's just kind of interesting. They would include that. That's is that number 4? Where do they? I'm not seeing. Oh, here it is. So yeah, the value of each work package is the sum of the personnel costs. Yeah, 110 bucks an hour for everyone. That's not too bad. But yeah, they've got to work with the state, because they have to do things proper, and I can respect that. Because Maunakea is a amazing place, absolutely amazing. I have never been to the top of Maunakea. Gotta say, I wish I would have made it up there, but nope, didn't get a chance. I'm just catching up on the chat here. Uncle Bill, automotive manufacturers, yeah. Yep, absolutely, Arnstro. Oh yeah, is there a 400K for a meeting and a review? Let's see.
You mean 401k?
No, meetings and review. $400,000. Pretty good.
Oh, okay.
That's one heck of a meeting. Hey there, Daniel. Nice to see ya. 400,000 for meetings and review. That's great. That's great. I hope they have a lot of fun there. Not quite sure what science level of effort means. That's kind of an odd term too. Yeah, so these are just sort of human costs. Public outreach. Look at that. 400K. Nothing on safety. Who cares about safety, right? Product assurance. I'm not quite sure what that is. 37,000. Yeah, it's kind of interesting, to look at the details, nerd out a little bit on those. Yeah, so permits, we got to get permits and all of that. So yeah, so pretty cool. I wonder if they have any idea about when they see this actually operating. Wow, I didn't see anything about that in this. Yeah, maybe they can't. Maybe they really can't, because it's so incredibly early. I mean, it's just a concept, right? But I would think that they would have a wish, but maybe it's not appropriate to put your wishes into these kinds of papers. Although those meetings, for 400K, that's a big wish that's that's probably going to come true. So yeah, I didn't see anything about that. All right, well, cheers, everybody.
I think the level of effort has to do with billable time and effort at a given strata. Scientists versus management.
Yeah, it that sounds like some kind of an accounting term. So yeah, it's probably some percentage of some total. Yeah, who knows? Who knows? Anyway, pretty exciting stuff. New instrumentation. And wherever I read that, let's just look. I really have to see because I thought I read it in this one. They were talking about how much data um, was coming through. Let's see. Program execution, direct observations, and I could have sworn I saw that. Maybe I saw it in the other paper. Sure. I would think it would be in this one though. Shoot. It was a big number. There was a lot of data. But I'm not seeing it here. I'm not seeing it in this paper. Maybe it's in the other one. That's all I can think. So I thought it was near the beginning. All right, look. We're just going to look really quick. I promise. I am mindful of the time. But, this is astronomy and this is instrumentation. This is like big, I mean, it's sort of disrespectful, but I like to call them, the big toys. That's a little disrespectful because they are not toys in any sense of the word. And if you want to treat them as toys, there's the door. So yeah, but they are. That's sort of how at least I feel about them. I definitely do not treat them as toys. No way.
Not a chance.
Not a chance. They are way too cool to mess around with. So I'm looking here to see if. Okay, so I guess this is probably what I saw. Is that collecting tens of thousands of spectra every night. So that's pretty impressive. That's a lot of data. A lot of data coming in. So yeah, that must have been what I saw. All right, well, cool. So yeah, check these out. This is the Maunakea Spectroscopic Explorer. It's a brand new telescope, right? That's going to be used for a single purpose, and that is to look at the spectra of thousands and thousands of stars simultaneously at different resolutions. So it's very, very cool. They've got a big scope. They got a big instrument. It is going to deliver some amazing data, but it's going to be really hard for sure. Yeah, check these guys out. I've got them. I've got a link to these papers over on my Discord server, which I think Uncle Bill posted earlier in the chat, right? Maybe at the beginning. Yeah. So, and I think I've got a link to it down in the description too. So join up on the server and yeah, see what's going on over there. So I'm going to stop sharing because I think it is time. What do you think? Is it about time, Bobby?
Getting close.
I think it's about time. With with my excitement today, um, I am definitely in need of some fuel. Almost out of fuel. So got some good lube though. Excellent lube. Cheers. Yeah, I think they are having to get some kind of new approval, um, uh, and that's probably the they're extremely respectful of the natives and want to make sure that everybody is happy and everybody wins, right? So just from sort of the glancing um, I gave it, it sort of looks like they do have to go through some kind of um, of some kind of an approval by the state, right? So, but that yeah, I mean, you're exactly right. I mean, it's not as if they're bulldozing a new site, right? They they have a telescope there. They're just gonna you know pop the old one off, put a new one on. It's pretty cut and dry, I would say. Yeah, I don't think there's going to be any kind of problem. On um, on the contrary, right? Probably what the natives are going to do, or what the natives do up on Kidd Peak. Very rightly so. But it's like, where's my piece, right? Where's my piece? And you know, the Hawaiians are probably saying, okay, bigger telescope, bigger check. And that is perfectly fine. Nothing wrong with that at all. I think that, I mean, if that's what makes them happy, then it's like cool. It's very cool. And you know, their um their spots um uh are being used for absolutely amazing things, right? Absolutely amazing. It's not as if we're just bulldozing and walking away, right? We're bulldozing, but uh, we're doing something extremely profound and beautiful and inspiring and all of that, right? So what better use uh, of that land except for leaving it alone, which may be a better use, but at least the next best use uh, is to use it for astronomical things. I think that's a great second use. So, all right. With that, I am going to get out of here. And yeah, I want to know what they're going to be doing with that 3.6 meter telescope. Where's that going? Who's getting it? I want to know. if you know, if they need somewhere to put it, okay. I'm at a very dark location, so you can just land it here. You can bring it in with like a helicopter and just sort of and then I'll take care of the rest. Thanks. All right, you guys, I'm gonna get out of here. I'm gonna go get some calories and just chill out the rest of the night. It's always great after these live streams. Um, it's just nice to relax afterwards. It's really great. So, all right, take care, everybody. I will see you on the spin tomorrow. Don't forget to subscribe, hit the thumbs up if you haven't already. Spread the word. Spread the word. We're looking for our core group, and I'm not trying to cast a net or anything at all. I'm looking for, being able to harpoon, right? Get you guys that way. So, all right, take care, and I will see you on the spin. A little less than 23 hours from now. Bye.
Later.